Allah, if you are kind enough to start the recording. Thank you.
Recording
Thank you.
started.
Thank you. Once again, good morning. Thank you for joining. Happy Friday. And as you know, this call is being recorded and we place our recordings on our YouTube channel. So if you don't want to be recorded, you may want to drop off now. Okay. So with that, today's topic, we are going to be talking about BCDR, basically business continuity and disaster recovery planning for your managed AKS applications, what things you need to look at. And just a quick disclaimer, we are not going to be talking about some of the kind of, you know, uh, some of the AKS basics. We just, as always, we do a quick loop around. So just want to give a quick heads up. But I mean, the links would be there. So if you want to do a refresher, you should be able to do that. So here's the quick agenda. We are gonna first look at quick Azure failover basics because these are the key concepts that especially with the in regards to IIS. We will talk about that. Then we will do a quick loop around a minute on what is Kubernetes and what is Azure Managed Kubernetes, which is AKS, and then look at some of the BCDR concept, what things you need to look at when you're planning it, and then we will look at different pieces of AKS architecture that you need to protect to build an AKS plan, and we'll look at some examples. So yeah, I mean, uh, I think we have a little more content than I anticipated, so we may be right on time today. So let's quickly move on to the next slide. Okay, so first of all, quick concept of availability sets. Before we go into availability sets, let's talk about update domains and fault domains. You may have heard this in discussions around Azure HADR. So, what fault domain is a single point of failure in Azure. This is going to be a server rack which has one power and network connection. If one of those goes off, all the servers on that virtual servers on that rack are gone. I mean, they're basically out of commission. So that's your fault domain. Update domain, basically, when we are applying updates to servers in a region or sorry, in a data center, we do it in kind of a waves. So we as kind of a select a set of servers, apply updates, and then move on to the next set. That is called your update domain. So if your application is using availability sets, so let's say you have a set of VMs, you deploy them and say, okay, there should be a part of availability sets. Azure will automatically put them in separate update and fault domain to make sure that if um, a fault happens or an update happens, your application doesn't go down entirely. You may lose some server, but you don't lose the entire application. But just keep in mind, you have to spin up multiple servers for that. So that's the availability sets. Okay. That's related to infrastructure. Just keep in mind for past services, such as app service and things that don't apply, and that discussion is out of scope of the topic today. So just keep that in mind. Availability zone. Most of the regions in Azure support availability zone. And just to kind of make it easy, I heard one example which kind of makes sense to me in regards to what a region is, what is an availability zone, and what are data center. It's like region is like a big pizza pie. Each slice is an availability zone, and topping on that slice, that's your data center. So each availability zone can have multiple data center. Just keep in mind, availability zones can be physically separated or logically separated. In certain regions where we have kind of a I mean, you will see like I think Singapore, they are kind of one on top of the other, but in other regions, we have physical separation. I think that is discussed in one of the articles, blog articles that is published on that topic. But coming back to our discussion here, what availability zones do, each availability zone has a separate network and power provider. So if one of the, um, let's say that if one of the network provider or power provider goes down, that zone may be dark, but other zones are functioning. So if you are deploying your application, let's say a VM scale set or a set of VM, and you said, okay, you deploy it and deploy it, make it zone redundant or deploy in a different availability zone, intentionally, then your application will still be running. Okay, though it may not have all the VMs there, but it still be functional. So that's the concept of availability zones and availability sets. Just keep in mind, very important. If you are using availability zone, you already have availability set. I had a discussion with a customer where they asked me like, okay, can I have both availability zones and availability sets? Zones are a superset. If you have them, you have availability sets already because you're already in different, your VMs are already in different fault domains, and at the same time, since they are different zone, they will be on different timelines for updates. So they're already in different update domains as well. So that's a superset. You go with availability zones where they are available, you already have availability sets. So let's quickly move on to any questions before we move on to Kubernetes basics. Okay, so quickly let me just build this slide since we are a bit short on time. So this is Kubernetes cluster. You have nodes, which are basically virtual machines. You have two types of them, worker node, which runs your applications. Your application runs in a pod, which is, just keep in mind, pod is not a container. It's a set of containers. It's a construct specific to um, Kubernetes. A node can run multiple pods. You have management nodes, which are doing the orchestration, scheduling, management, all those kind of things. And there is master node. There is a set of master nodes, which is kind of part of Kubernetes control plane, and then you have worker nodes. Okay, and you can have each worker node is a part of a node pool. You can have multiple node pools. Okay, so that's how Kubernetes function. Um, very powerful in a sense that you have a lot of knobs and switches to make it uh, work for your workloads and a lot of very powerful feature. But at the same time, there is complexity associated with it, as we know that with more power, comes more sometimes more complexity. So look at this. This is the Kubernetes without Azure, and this is with Azure. You have so what Azure is doing is it is taking over the management plane of Kubernetes. Master nodes are now provided by Azure. It is hosting them, and you are only paying for the worker nodes. That's where, I mean, node pools. That's where your apps are running. We are providing an SLA for your the management plane, and we will talk about it in a second. The thing is, it gives you best of both worlds. First of all, it allows you to deploy the entire Kubernetes infrastructure with the click of a button. You don't have to worry about, okay, what machine I need to deploy what. Second, the management plane is now taken care of Azure. You just worried about your worker nodes and things like that. Third, you still can take advantage of the full power of all the Kubernetes API like kubectl and things like that, just like you will do with any other cluster. Fourth, you can take advantage of Azure services like Azure monitoring and storage and things like that. So best of both worlds. Okay. So now let's talk about I have this slide for a reason why I have this all the big font. Number one, there is no one plan for every application. Every application will have a different plan based on their RPO, which is recovery point objective, RTO, recovery time objective, uh, SLA, commitment and things like that. No, I have customer ask me, hey, is there a document that I can use for which which tells me how to do a BCDR plan. Where's the BCDR plan I need to build? You, there are principles of that you can use to build your own plan, but there is no one plan because every application is different. And just keep in mind, there may be a plan that you can find, which you seems kind of a very, nice and all, but it may be very expensive to run it in terms of operationally and in terms of cost wise of so that kind of that should come into your that should be one of the deciding factor, you know like how, I mean, if there is a plan, what is the cost of that plan, what it takes to run that plan in the case of failure happens. So just keep that in mind. Okay, I will stop for a second. Any questions?
Thing in the chat, Naveed, so far.
Okay, great. Thank you. Okay, so this is kind of a quick definition. I'm not going to read the slide. This is a journal BCDR. Basically, here we are talking about how you deal with failure, and both of these are kind of tell us how to deal with failure, how to run your application when a failure happens. One is how you recover from it, which is a disaster recovery, and one is like how you continue to work while the disaster is happening. There's an outage or some sort. So that's what we are going to talk about. And what we are going to do is we are going to look at different AKS components and see what are their kind of a fault point and what we can do to improve, I mean, make them fault tolerant. Okay, and that's what we are going to be discussing here. So first of all is your pod. Pod is the kind of smallest or kind of the lowest component that runs your app. I mean, that's if you are deploying your application in AKS, it will be once you deploy it, it will be run on one or more pods. Smallest component in AKS. So that's it's a set of containers, runs your application. Simple. Node. Node is a virtual machine that is running the pods. One or more pods will be running on a node. Okay, so that's another component that we have to worry about in regards to fault tolerance. Then we have container registry. Okay, you may say why container registry is there? It's not a component of ACR or AKS. It is there because you will be deploying your image if it is not a demo application or something from a container registry. Okay, so these images will be getting there. The image will be stored there as you are containerizing your application, making updates to it. So it is important to think about if you fail over, what will be the impact on ACR or Azure or normal. Okay, so in Azure, you will be using Azure Container Registry. So we are going to talking in that context. Okay, then you have the cluster. So cluster is a set of nodes where your application is running. So you have nodes, you have pods, and you have cluster. Cluster is nothing but a collection of nodes. Can have multiple set of nodes called node pools. API server, this is the management plane we are talking about. This is where you're going to be sending your commands to make changes to your cluster to, in a sense, like applying applications and things like that. That's your API server. And finally, storage in just keep in mind in Kubernetes in container storage is ephemeral. So if something you make changes to it or you store some data Once a container dies, that storage is gone. If you want to use persistent storage, then you need to use volumes. Okay. And I want to give you a heads up, a discussion on storage replication is out of the context of this because it's a very broad topic. There are a number of options from disk, so we will not be talking about it. For example, you can have disk, your application may be storing data in Azure SQL or MySQL or other databases or Cosmos DB. So that's another uh, uh, big discussion that probably have made deserve its own session. So we are not going to be talking about it, but and that is very well documented how you replicate that. So I don't want to kind of take time from this session to talk about it. So let's talk about first of all in regards to the pod. So if let's say that you deploy your application and you ran one pod. I mean that application is running on one pod. Okay. Let's say if that pod crashes or something happens to it, your application is gone. Something happens to the node on which the pod was running, your application is gone while AKS is scheduling up that pod on some other server. Okay. What you can do is you can run multiple pods for your application. But let's say it schedule both pods on the same node. What will happen is if that node goes down, both of these pods are down. Once again, your application is down till AKS finds another node to run those pods. That's where these three kind of a pod characteristics, these are some of the kind of metadata tags that you can apply to make sure that your application uh, continue to function in an appropriate manner. For example, pod anti-affinity. You can make with that, it will not put the pods from the same application uh, on the same node. It will try to put it, schedule it on different node. Okay, so this is to avoid the scenario that I just described, where a node goes down, your application goes down. That's one. Second is readiness probe. So let's say your application come up. So AKS is going to decide, okay, yeah, your application came up, and as soon as the container comes up, it's going to say, hey, let me send traffic to your application. But let's say that your application is still doing some processing. It is waiting for some backend services to be ready, just doing some other stuff. In that case, that application is not ready and you will still get some errors while this is getting ready. So what you can do is you can have these readiness probes which AKS will check before you're bringing your pod, sending traffic to your pod. So that's another thing. The third one is pre-stop um, command. So this is very important. Let's say that your application is taking traffic, but now you need to upgrade your, shutting down your application or your pod needs to go down because you're deploying another version of your application. But still, there are connections to your application. This command will help you kind of AKS will check, are you still taking traffic? And while uh, and based on these commands, it will make sure that once all the connections are drained out, then it will bring that pod down. So this will once again um, help a smooth transition for your application in the case where there are kind of a you know issues happening with the cluster or where there are upgrades, application upgrades that you're going with. Okay. Second one is the at the node. So nodes are, as I said, a virtual machine which are running which are running like Kubernetes software, and then you have pods running on top of it. So what do you do with them? Once again, They will be, as you can see in AKS, you can do a zone redundant deployment. They are run as, in the case of AKS, they are run as um, VM scale set. So you can do multiple nodes in a cluster just to make sure that there are enough nodes to support your application, and you can do a zonal deployment. Oh, sorry, a zone redundant deployment to make sure that if one of the zone goes down or one of the data centers in a zone goes down, your application is running, your application still stay afloat. Okay, so that's how we address that. In regards to container registry, ACR supports multiple ways. You can have premium ACR, which is also zone redundant. If you are doing a geo redundant deployment, you can you can use geo replication of the registry. So that will address that. And as we go to the cluster, we will look at some of the approaches, what you can do. You can do have cold, warm, hot DR sites. You can have blue-green deployments. You can have geo-redundant deployment. I mean, all, as I said, there are options available, but once again, you have to know what is the SLA that you are going against. In regards to the API server, it's very important. AKS gives you the option if you are using a availability zone, it gives you a 99.95 SLA for the API server. If you are not using availability zone, it gives you a 99.9 SLA for the API server cluster. So that's that. And as I said, for the storage, we already talked about it. That is, we are not going to be, discussing in detail what are the storage option. Depending on the storage solution, you can pick one of the option. There's a lot of detail there, and that's kind of depends on the storage. That's kind of not a part of this discussion. So that's why I left it out, because it's a very detailed topic which can one, if not more, sessions. So with that, let's go over some diagrams. Any questions? Okay. So this is the kind of a very high level first. Um, you go in, you deploy your AKS cluster, you make it zone redundant, and that's where you are deploying the VMs across different zones. And you don't have to do it once you kind of set up your AKS cluster as zone redundant. AKS Azure will go behind the scene, take care of that deployment by itself, and it will make sure that the nodes are deployed across different zones. Okay, so what it will give you? It will give you zone redundancy in a region. So if one of the zone goes down, your application will not go down. Okay, your application will still stay up. Yes, if that region is suffering the outage, then your application is down. So that's where you have to think about it. What is, as I said, I'm coming back to it again and again and again. What is your SLA? You know, uh, and do and that will dictate. I mean, do you need a kind of a multi-zonal um, um, or multi-region deployment? Any questions? Okay,
Yes.
so go ahead, please. Yes,
No, no questions so far. I'm
no
just
question.
like, but
Thank you.
folks, feel free to write on the chat. I'm happy to read them to Naveed.
Thank you. Thank you. So this is the one that is, uh, I some of the customer teams that I talked to, um, they started with 100% SLA and all these things, and then when we discussed, as we kind of a dive more into it to their requirement, a number of teams are using this type of deployment where they have active deployment in a region, and where they have their zone redundant AKS cluster, all the things running fine, everything is running. And then they have a second region where they have the basic setup. What I meant by basic setup is virtual network and some of the basic storage and maybe a kind of a whatever VNet and NSGs and things like that, which don't which cost very little or kind of think of it as a hot standby kind of a scenario. And then they have their DevOps pipeline set up where if they want to build this infrastructure, they can quickly build it in less than an hour. And I'm just to being very conservative, an hour. I mean, some teams were able to do it in like 15 minutes. So a disaster happened. They quickly built up their zone redundant cluster in a different region through their DevOps pipeline. So everything, there's nothing manual here. Basically, it's just a pushing a button and everything spins up. They test it out, quick, sanity check. Everything is kind of a replicated in the other region, and all the dependencies are there, and suddenly their cluster is up and running in another region. And there are different flavors of it. In some cases, they are not creating all the backend system there. They have the backup, so they restore it. In that case, the time can be a little bit more. In some cases, they have the backend systems there replicated, so they're ready to go. But the expensive piece, which is the AKS cluster with a number of nodes, that is that does not run unless until a disaster happens. Think of it. This is a solution that I have seen a number of customer teams using it because kind of gives them flexibility in a sense that, or I mean, it's a cost optimized solution. Yes, it is not active, definitely, because I mean, you have two regions and their failover. Um, it's not kind of a failover, it's basically you are spinning up another region and then pointing your applications to that. Some teams they're using kind of a abstraction, something like a traffic manager or what you call a front door to do this load balancing, but that's depending on their particular solution and things like that. But that's one of the solution that I have seen teams implementing. This is a blue-green deployment. So this is same region. This is to avoid any downtime when you do a AKS version upgrade. So, with AKS version upgrade, though it allows, in-place upgrades where you can upgrade the same cluster, it does the rolling update, takes a node, update it, and then move on, works well. But at the same time, if for some reason your application fails, then situation can be a bit more complex how you go back to the previous version. In this case, what they do is they have two clusters running. The green is which has the current version, and the blue, which is going to be the upcoming version. It's not always running. It only is there when the new version arrives. They deploy it, they test it out, everything is all good to go. Their application, then they do the switch. Basically, becomes green and green becomes blue. You have an application gateway sitting in the middle, which is kind of making sure that the end application is abstracted out from the changes behind the scene. Okay, so that's kind of a blue-green deployment. Okay. One more. This is the cross region. This is one of the more expensive one. You have multiple deployments across regions. One, region two, both are zone redundant, both are active. You're constantly replicating data between these two, and you have a front door or something like that sitting there as a global load balancer to send traffic. Both of these are traffic. Think of it, this is the Cadillac of a kind of a BCDR plan, and it is needed for those applications which cannot take a downtime. So that's will be applicable in that scenario. I know we are a bit over time, so with that, that's pretty much we have to discuss. I have some resources here, so just want to share some thought on it. Please feel free to provide any feedback or things, and thank you for your time, and hope to see everyone next week for another session of Azure Power Lunch. Thank you very much.